Okay, I hope everyone's having a fun time studying right now. I'm just going to quickly go over each step of the lab report. I didn't do the best job explaining it today, so I thought I would try to elaborate a bit. This can just be used as a way to kind of check your answers, make sure you're on the right track. First thing, each row here is going to be worth 1 mark. So this filling in this chart is worth 2 marks total. Now the first column here is just asking for magnification. All you got to do is multiply the objective lens, which is this right here, number 4, times by the ocular lens, which is something you should know. It should be in your textbook. So you take your objective lens, which is 4, multiplied by your ocular lens, should give you your answer here. You do the same thing for high power. You take 40, your objective lens, multiply the 40 by your ocular lens, and you should get a magnification for here. The field diameter. This is something that you should have measured in class today. You should have had a ruler that you put under the microscope, and you should have seen how many ticks the ruler took up. So this is something that you get from actually doing. Now this one right here should be calculated. Now we're going to go through the calculations step by step here. You should have not been able to just gotten this answer from putting your ruler under the microscope, because the magnification should have been too high for you to see the ruler. So what we'll do is we'll identify each variable here. So low power magnification. What that is it's just the lower number between these two. So say this is a 1 and this is a 2. You're just identifying what's the lower number. So we'd put a 1 right here. For high power magnification, so you're just looking for the higher number of the 2 now. So let's put a 2 right here. Now you're looking for low powered field diameter. What this means is that when the magnification is low, what is the field diameter? So again, we're looking at this. Which one's the lower? Number 1 is the lower one. So when it's 1, what's the field diameter? Which is something we should have measured today. So you put that number here. And then high powered field diameter. So when the number is high, it's 2, what's the field diameter? So that's what we're looking for. That would be your X. Now everything else should be filled in. So what you do is cross multiply. So you take this number here, you multiply with this number, right? Multiply with that, and then you divide by this number. Okay, it's a little messier right there, but you should get the point. In micrometers here, you're just converting units that you get from this column right here. Okay, moving on to the second part right now. For the scientific diagram, it's worth 4 marks. Okay, so you get 2 marks for the actual drawing of the diagram. 1 mark for the title, 1 mark for labeling. Okay, labeling and making sure that it looks like an actual scientific diagram. So something that you actually observed in class today. Okay, so that's 2 marks. Okay, 1 mark each for each of these boxes. So this is 1 mark, this is 1 mark. Okay, how do you get the actual size? Well, you take the field diameter, which is what you have right here that you should have calculated. Okay, should have calculated the field diameter, and that's what you'd be using for right here. So pretend that we just got like a 1 right here. Okay, it's got a field diameter of 1. Okay, so you take a 1 right here. Okay, and you're dividing by the number of objects across the field of view. So this is the number of cells that you saw across in your microscope. So count the number of cells that you saw across. So pretend like this drawing is something that I actually saw under my microscope. So in this case, I saw 1, 2, 3 cells. So what I would do is I would just write 3 right here. It's making sure I have my units, 1 millimeter. So essentially I would have 1 millimeter, which is my field diameter, divided by the number of objects across my field of view. So my actual cell size would be 0.3 millimeters. So that what that's saying is that 0.3 is the actual size of an onion cell, an actual real life onion cell that you saw today. Second thing, calculating the scale. So what you're gonna want to do here is you're gonna take a ruler, a real life ruler, and you're gonna measure your physical drawing. So whatever you have drawn right here, take a ruler and measure one cell. So I'm just gonna measure my middle one with the pretend ruler here. So this ruler was actually accurate. It would be, let's see, be 1, 2, 3, 4, 5, be 6 millimeters. So this cell in the middle here is 6 millimeters. So then what I would do is I would write 6 millimeters. Okay. And I would divide it by the actual size. So this is your actual size right here, which is 0.3. Okay. So I would just put this into my calculator and it should give me this answer right here. Now for some of you math people, like myself, it's kind of weird to put, say you get a decimal or like a fraction, it's kind of weird to put a decimal number into a ratio of 1. But for our purposes, just ignore that. Just divide your diagram size by your actual size, so whatever you have right here, and just put that answer right here. It should give you the correct answer. Okay, moving on now. Discussion. Right here, this is worth 2 marks. So what you're going to want to do is just state the relationship between the field of view and the magnification. So I'm looking for answers like, is it a positive linear relationship? Is it negative? Is it exponential? Kind of words like that. And then identifying what happens to the field of view when increase in magnification happens. So does it field of view decrease? Does it increase? Does it stay the same? Something like that. Question 2 now. And this is just kind of summarizing everything that you've kind of done. So again, they're stating what you have. So it's stating that you have the magnification. So again, it's stating that you have the low power magnification and the high power magnification. And it says right here that you're given the size of the field diameter. So it's giving you these 3 boxes. So to estimate an object viewed under high power, you'd want to solve for this box right here. So I want you to just write down the steps it takes to get this box. Okay, but we're not quite done when we get this box. There's another step, which one method you can use is something that we already went through. It's just taking the field diameter, which is this box, okay, and dividing it by the number of objects that you see. Okay, so just writing that into actual words. If you're more of a numbers person, then feel free to use hypothetical numbers. Okay, and that's worth 3 marks, just showing your work or just writing down the steps. It should be 3 marks worth of things. Question 3 here is just state the 3 components of cell theory. This is straight from your notes and the textbook, so I shouldn't see any issues with this one. Conclusion, this one's big because it's worth 4 marks. So first thing I want to do is going to summarize what you did. So what you actually did in the lab. Second mark is what you found. So kind of the results, things like that. Third mark is this simply saying whether your hypothesis is correct or incorrect. There's 1 mark for that. Simple answer. Fourth and final mark is this why or why not it is incorrect. Now I hope that made the lab a little bit more clear. If you had any questions, if you still have questions, feel free to send me a message through Google Sites. I do believe it has a messaging system or a discussion type of system. So I will be on it tonight, and I will be more than happy to answer your questions related to this lab or related to your in-class assignment or any notes. So I hope you have a good night and study hard, and I'm excited to see you all tomorrow.